how an aircraft communicates. So aircraft also has this need to communicate with other aircrafts and also with the grounds. However, the communication systems of an aircraft is not so easy. Talking about the different systems present in an aircraft, just like the mouth and ears that we have as a human, there are different antennas embedded in an aircraft. So here we can see a Boeing 787 antenna. Basically, the antennas can be divided into three different types, that are high frequency antennas, very high frequency antennas, and SATCOM. So I'll be describing about these antennas in detail in upcoming steps. However, how does an aircraft actually communicate? That's the theme of this video, and we're going to discuss about the different systems present in an aircraft system and the language that they use to communicate. So initially, starting with the problem here, back in the days, the communications were done vocally by a pilot. However, the need for the communication started increasing, and the communication increased rapidly so that a pilot or a crew member could not handle large amounts of data. So this is how there was a need of a communication system, and ACARS is the solution for this kind of problem. And this is a pathway to a rigid and efficient way of communication, not just between the aircraft, but also between aircraft and ground. There are many vital informations that are required from an aircraft to perform its daily task. So the main function of the communication system is to report flight informations. There are thousands and thousands of informations that are recorded during flight real time, which needs to be transmitted to the ground station so that they can be analyzed and problems can be predicted and prevented. So before 1978, flight information was registered and transmitted with high frequency antennas and very high frequency antennas. However, this system had a huge flaw because this communication system was based on human capabilities, and it was vulnerable to human error and it lacked accuracy. So what could be done to improve this situation? That's why a system of sensors, a communication system, and ground stations was introduced, where use of sensors in different parts of an aircraft was channeled to that helped the system to operate in an efficient way. And this combination of sensors, communication system, and ground station is what we call ACARS system. So ACARS system is aircraft communication, addressing, and reporting system. So it communicates with other aircraft and ground systems and reports the data is being transmitted. ACARS system has different scopes. So aircraft system not just communicates between aircrafts but also between ground station and aircraft. This system has variable range. So if this system uses very high frequency, then this is limited by line of sight. However, it is very reliable at further distance. SATCOM technology is used, which is limited by polar regions again. And to overcome these limitations, high frequency antennas were used, which were primarily used in polar regions. We could also talk about the ACARS components. So there are different components in an ACARS system. So one would be onboard system, another would be ground processing system, and at the end, data link service provider. So onboard system includes MU and CMU, that is management unit and communication management unit. This has the capability to choose the most efficient air-ground transmission method available. So within these three options that are available for an aircraft, the system could select the most efficient transmission method in a given context of the aircraft. And ground processing units are either an ANSPs or aircraft operators as the need be. And at the end, the data link service providers are mainly ARI and C and CETA. So these are the only two providers that are there to provide a reliable data link between aircrafts and ground systems. Talking about the data actually being transmitted, there are different kinds of data that are being transmitted. First of all, the data could be divided into three different parts. Is divided as per the recipient of the message. So first would be ATC message. So air traffic controller would get this message. This would be a communication between air traffic controller and the aircraft, and the other one would be aeronautical operational control. This would be a communication for aeronautical operations, and AAC, which is airline administrative control. So air traffic controller message, this includes the aircraft request for clearance, air traffic controller instructions to aircraft pre-departure and clearance, and en route or ocean clearance are also done through this kind of message. And talking about the AOC message, they are basically divided into two. One is enhance airline operations, and the other one is navigation information. So the first one would be used to enhance the airline operations. That means this information includes the informations about the flight, which increases its efficiency, reduces fuel uses, ensure timely communication and information transmission. This also includes logistics and data collections. And navigation information, of course, includes the aircraft positions reporting, departure clearance, ocean clearance, weather and runway conditions, and NOTAM, that is notification to airmen. And airline administrative control includes the communication to the base about the problems in the flight. Having said that, the classification could also be divided into a different dimension, that is uplink message and downlink message. So uplink message is the message that is transmitted from the ground station to the aircraft, and downlink message is the message sent from the aircraft to the ground station. So uplink messages include the pre-flight messages like flight plans, fuel load sheets, weather data like NOTAM. During flight, sudden change in weather could also be reported with this uplink messages. And downlink messages include UI messages. UI is a special kind of set of messages that are sent to the ground station from an aircraft, so that the aircraft flight path and the airlines could maintain their flight schedule. So first O means out. So the out of gate off block time when the aircraft leaves the gate. This is usually logged when the sensor records the last door closed, either cabin door or cargo hold, and parking brake release. So second O is for off, the time of takeoff. So this time is triggered by weight of wheels sensors that are triggered when the aircraft leaves the runway. So there is a sensor in the wheels, and when the aircraft takes off, the weight of the landing gear is relieved, and the pressure sensor or some kind of sensor there sends a signal saying that the aircraft is off the ground. So this on time is the landing time and is recorded again by the weight on the wheels when the aircraft touches down. And at the end we have in, that is the in time is the time of arrival at the gate. The in time is triggered when the parking brake is set and the engines are shut down. So this is the end of the aircraft's flight leg, and this is sent through the ACARS system automatically, and this helps the aircraft transmit all the necessary information without any headache to the flight crew or the pilots. So this is a fairly complex system that works. This system transmits a lot of informations at a very high speed, and this is much more efficient as compared to a human who has to send out informations every now and then, reporting about the flight situation and weather information. So This is this is how aircrafts communicate with each other and also with the ground.